All right, so we're taking a look today at graphing quadratic functions and graphing absolute value functions. So for quadratic or absolute value, we basically always want to find the vertex first. That's the turning point. All right, on a quadratic equation, the generic formula in terms of algebra is x equals negative b over 2a. For a lot of our purposes, we can just use the graph and either find the minimum or maximum value, depending on if it's concave up or concave down. Remember, concave up is smiley face, down's a frowny face. And this vertex is going to go right in the middle of our table. All right, so we're going to set it up so it's right in the middle. And then what we're going to do from there is graph the points above and below. So we want to pick 5 points above and below. You might need more depending on how many points you can fit on your graph. If you need more points, just add more to your table. All right. And then the same thing with absolute value. So at least 5, minimum, max in the middle. Remember, the general formula is a and then absolute value x minus h plus k. So this coordinate h comma k, remember, is essentially where the graph is going to be, where the vertex is going to be. All right, so opposite of the inside, same as the outside for our point on the graph. And we'll take a look at it in a second. So for the first one, it's y equals x squared minus 4x minus 1. So we would do a new graph, not new documents, new graph. Okay, we're going to type in x squared, all right, minus 4x minus 1. There's a graph. We want to find the vertex, so we're going to go to Menu, Analyze Graph. We go Minimum, and we're going to choose our value. And we can see that it's the point 2, negative 5. So on our graph here, we're just going to slide this over, a little bit of room. We're going to make a quick table, x and y. 2 is going to go in the middle, and we're choosing points above. So 1 and 0, 3 and 4. We know it's 2, negative 5. And then we're going to go above and below. Now remember, it's symmetric. So we get the table, we just can press Control T for the table. And we know that at 0, it's at negative 1. 1, it's at negative 1. At 1, it's at negative 4, negative 5, and then it's symmetric. So it's going the exact same points down. All right. So 0, negative 1 is right here. All right. So 0, negative 1, 1, negative 4, 2, negative 5, and going back up. Now, because we're only seeing these 5 points here, and it's not an interval, it only doesn't say what points to graph, we may want to graph a couple more. So we can see at negative 1, it's at 4, and then negative 2, it's at 11. We can't fit 11, but at negative 1, we can definitely fit 4, which means it's the same thing going over to 5. So we can add that to the table if we need to. Okay, negative 1 is 4, 5 is 4, and now I can graph my function. So starting at the vertex and going up. Remember, we don't want to cross over the line of 3, so I don't want to go over here because I know that it hits at 11 somewhere. So my graph should be ending up pointing at that point up there. And then the same thing here. Okay, please make sure the line tries to go through the points it's supposed to go to. All right, and then we got the graph, y equals x squared minus 4x minus 1. Now on our graph here, remember these points are referred to as the roots. There's the solutions to the quadratic equation where it's equal to 0. This is our vertex, all right? So the axis of symmetry is always x equals whatever the point of the x coordinate here, so it'd be x equals 2. And if this were, say for example, a pendulum swinging or something, this would be the minimum value, would just be the y value on the graph. The minimum value would be negative 5. So it's essentially looking for in terms of everything with parabolas. You don't always have to label all that blue stuff, but it's there. Okay, the second one we're going to take a look at is y equals the absolute value of x plus 1. So we'll insert a new table here, or just a new graph. So Control, Doc, Graph. Absolute value function is right here next to the 9 in the book. It's the symbols button. There's the absolute value, and we're doing x plus 1. All right, so you can see if it's supposed to be this, absolute value of x minus h plus k. We know it's the opposite of this, so we know that the vertex, essentially, the turning point, is at the point -1, and k would technically be a +0 here that we're not seeing. So -1, 0. So I'm going to do another table. I'll do this one in blue. Okay, I know the vertex is -1, 0. That goes right in the middle. And then I'm going to do points around it. So -2, right? -3, and then 0 and 1. So Control T. You can see that at -1, it's at, or -3, sorry, it's at 2. -2, it is at 1, and then it's symmetric, so it's also at 1 and also at 2, at 0 and 1. And we can see that right there. So 0 and 1. I keep hitting the wrong button here. Get out of there. All right. So we're just going to go ahead and graph those points. So we graph -3, 2, -2, 1, -1, 0, and we're going to get that V shape popping up here. All right. So let's go ahead and graph that for ourselves. So you can take your straight edge, just a ruler, bus pass. On the exam, you'll have a ruler. You can drop that out for yourself. All right. And then make sure we're throwing arrowheads on there. Okay. This should be located right on that point. So, and then we want arrowheads so that we know that it goes on forever in this case. All right. And then we have our graph, y equals s value of x plus 1. All right. Okay, so state the axis symmetry. For this one, we just did it as x equals 2. State the range of the function. So remember, the domain is x's. Okay. So domain is the x's. We don't know when it's increasing. So if you're looking at the graph, right, the graph is technically decreasing as it moves in this direction, right? It's going down. So it's going down here, decreasing, decreasing, decreasing. This is where the value starts turning, and then it's now increasing in value. So anything after this point is increasing. So we would say the domain is increasing, okay? Let's change a little bit. All right. Okay. It's increasing all values of x greater than, in this case, -1. And you could also just put down where x is greater than -1. All right. And then the range, and same thing, would be y, and then it's going to be anything greater than or equal to 0. Okay. So give me some math. Greater than or equal to, and then 0. There's our range. All right, second one, solving equations by factoring. This is where we're going to use our diamond and possibly our box here. Okay, so for the first question, we need to essentially just solve. So we need to get it equal to 0. So we're going to write out anything like this, we're going to write out twice. So it's y minus 3 times y minus 3, and then equals 4y minus 12. We're going to distribute. So this is y squared minus 3y minus 3y plus 9, right? Equals 4y minus 12. Okay, we're just distributing the y through and then the 3. So that's how we end up with this. We're going to combine like terms. So y squared minus 6y plus 9 equals 4y minus 12. We need to get it equal to 0. Okay, so we're going to move the 4y and the 12 over to both sides. And we get y squared minus 10y. And we're going to get 21. So plus 21 is equal to 0. And so if we do the diamond, I want two numbers that multiply to give me -21 and add or subtract to give me -10. So if I'm looking for numbers that multiply to get -21, -10, we're gonna So this should be positive 21. So we know they're going to be the same symbol because they're both positive or getting a positive result when multiplying. So we know it's going to be negative 7 and negative 3 because it's got to be both be negative. So if y minus 7 and then y minus 3 is equal to 0, and then we set each equal to 0. So y is equal to 7, y minus 3 is equal to 0, y is equal to 3. We have that or right line down the middle, and there's our solution. So the solution set is the set of 7 and 3, positive 3, not negative 3. Get out of here, you. And there's our solution set. All right, 206. Amy solved that equation. She stated the solutions were 7.5 and negative 6. Do you agree? Explain why or why not. So we could take and plug them in and see if that works. And then we could just say yes because it works, or we could actually solve it. So if we solve it, we want to do the AC method. Remember, we're going to multiply the first number and the last number together. So 2 times negative 42 is negative 84. We want that to add or subtract to 5. I'm looking for numbers that multiply to 84 and add or subtract to give me 5. So what I could do is if I want to use my calculator, this, I can take 84 and I can start dividing it by numbers. So let's say we know 84 and 1, right? Easy one. 84 and 2, okay. 84 and 3. I'm looking for numbers that are going to add to 5. So 3 and 28 is like, that's not going to give me 5. 84 and 4, right? We're getting a little bit closer. 5 doesn't work because it gives me a fraction back. Let's see. 6 doesn't work. 8 doesn't work. So we're looking for those numbers that it's going to factor out. Now there's another option, which is if we do a graph, okay? And if I graph it, so 2x squared, okay, it's plus 5x minus 42. I can see where it's going to cross right here and right here. So I know the number, right? And kind of get the idea of what I'm going to try to use here. But the factors numbers I'm looking for are what we just talked about. Like if we do 84 divided by 12, 12 and 7. Hey, look at that, it gives me 5. So we can keep messing around with the numbers that way and come up with 12 and 7. So just go through and just try 5, 6, 7 and see what's going to work. Now it's a negative 84 and positive. So I know this has to be a negative 7 because I need a positive 5 in the middle here, okay? And now since the leading coefficient is 2, I know that I'm going to use my box. All right, so the first number in the box, the first term is the 2x squared, and then the negative 42 at the end. And then I'm going to put the 12 and the 7 in the two boxes, and the 7 is going to get negative. So 12, and these both get x's on them. So 2x squared and 12x have a 2x in common. Negative 7x and negative 42 have a negative 7 in common. 2 and negative 12 don't have anything except x in common, and 12 and 42 do have something in common. They have a 6 in common. And 12 is positive. This starts positive here. Since this negative 7 is positive, it's going to start, or sorry, negative, it's going to start negative. However the row or column starts is the sign of that factor. So I know that I'm going to do my two factors now. I know one of them is 2x minus 7, and the other one is x plus 6. And then I can set each one equal to 0 and solve. So 2x is equal to 7, and then x is equal to 7 halves, which is one of the answers, right? And if x minus x plus 6 is equal to 0, should equal negative 6, which is another one of the answers. So do we agree? Okay. Now we want to say yes or no, because it's asking us whether or not we agree. So we can say, yes, I agree with Amy, right? Since the roots, okay, or the solutions, I guess not the solutions. We would say since the factors 7 over 2. All right. Anything along those points. So if you're solving it, you can say that the solutions are, or I solved it myself and I ended up with the same thing. The roots of the equation are, any of those things will work here. So that explanation will fit. All right, using the square roots. Remember, when we're doing square roots, we always want to get that square thing by itself. Went too far. All right. And then take the square root of both sides. So for the first one, I have 4x squared minus 100 is equal to 0. Technically, I can factor this using perfect squares. So 2x minus 10, and then 2x plus 10. Actually, I lie, not 2x. Yeah. Actually, before that, I would actually want to take out a GCF first of 4, and then factor this thing. So this would be 4 and x plus 5, x minus 5, and then I would solve from here. Remember, this 4 does not equal 0, so it's going to drop out. However, if I'm using the square root method, I want to get that squared term, which is just the x squared by itself. So I'm going to move this 100 over first. So I get 4x squared equals 100. I'll divide by 4 to get the x squared term by itself, which is equal to 25. And then I'll square root. Remember, this ends up with a plus or minus here. So I end up with x is equal to plus or minus 5. And you can see we get the same solution over here. Same thing over here. We add the 5. So I get 4x squared is equal to 80. Divide by 4. So x squared is equal to 20. And then I'm going to take the square root. Remember that plus minus. So I'm going to get x is equal to plus or minus 20. And exact values, square root, we could factor this down. So 20 is going to become 4 and 5. 4 is going to break down to 2 and 2. So the square root of 20 is 2, 2, and 5. And then we're going to take out the 2's. Remember, the twins got loose, only one survived. So x is equal to plus or minus 2 square root of 5. And there's my exact value. All right. On the next page, quadratic formula time. So remember the quadratic formula? Right, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So first thing we want to do, though, is make sure this square term is positive. It's got to be positive. If it's not, start moving everything to the other side of the equation, divide or multiply by -1. Get it in standard form where it's positive, okay? If we can't factor it, we're going to use quadratic formula or completing the square here. So I know a is the coefficient in front, which is 1. B is also 1, and C is -5. So it's negative b, so -1 plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is -5, all over 2 times 1. Remember, this is the variable equal, so it's need an x equals in front. Now I'm going to take my calculator, and I'm going to type in everything in the parentheses here, okay? Not the square root, though. So 1 squared minus 4 times 1 times -5. And it's a pretty good idea when you're doing the square to use parentheses. So if that number is negative, you won't get a negative answer. And I get 21 here. So that x is equal to -1 plus or minus square root of 21 divided by 2. That is essentially the simplest radical form version of that, okay? However, it says nearest tenth. So I know x is equal to both -1 plus the square root of 21 over 2, right? Or x is equal to -1 minus the square root of 21 over 2. And so I'm going to do both on my calculator, okay? -1 plus square root 21. Parentheses there so I can close it off. I'm going to hit Control Divide, get my fraction bar, divided by 2. And then if I hit up arrow and grab it, I can go and just switch that to a minus. And there's my 2 answers. So nearest tenth would be 1.8 and -2.8. And there are my 2 answers. All right. 237, a rectangular pitcher measures 6 by 8 inches. Simon wants to build a wooden frame for the pitcher, so it will take up a maximum area of 100 square inches on the wall. Piece of wood he uses to build the frame all have the same width. What is the equation inequality that could be used to determine the maximum width of the pieces of wood the frame Simon could create? How does it model the situation? Inequality determine the maximum pieces in the wood. So if we have a rectangular pitcher frame that measures 6 by 8, okay? So we'll say 6 this way and 8 this way. So it's a little bit longer. All right. A maximum of 100 square inches on the wall. So we know it's got to be length times width, right? And it's got to equal 100. And the pieces of wood to build the frame all have the same width. So it's going to end up being a square. All right. So in order to have an area of 100, and I have to have the same number when I do length times width, it's got to be 10 times 10. Okay. So I know I want to increase the size to 10 times 10. So determine the maximum width of the pieces of wood for the frame Simon could create. Okay, so the timeout. Let's rewind. We got a little inaccuracy here. So first of all, the pitcher he has measures 6 by 8. We want to build a frame around the outside of it, so it's going to look like this. And I have to use the same inches of wood essentially. So I have to add the same amount on to every single side here, if you think about that, okay? And that number that I can add on to make my frame is essentially x. All right, so I'm going to add an x here and an x over here. I'm going to add an x here. So all of these little add-ons here are going to give me x, okay? This 10 times 10 thing, let's just forget that because that was a misunderstanding in terms of what we were looking at with the area. It's not a square frame. It's not the pitcher's not going to be square, the frame is. So if you think about it, this side from here to here, okay, has a measure of 8, and then I'm adding 2 parts that I don't know, so that's essentially 2x plus 8. And when I do this piece from here to here, okay, it was 6, and I'm adding on these 2 pieces that I don't know the length of, which is x. So this is 2x plus 6, okay? So in my question, I have one side that's 2x plus 6, the other side that's 2x plus 8, and when I do the area of this, it has to equal 100. So this is essentially how we're doing this question. So if I'm solving it, I want to distribute first. So the 2x through is 4x squared plus 16x. The 6 through is going to give me plus 12x, and then plus 48, and this is equal to 100. So I'm going to get it equal to 0 first, and combine like terms. So I get 4x squared. I'm going to add these together and get 28x. Minus this is going to give me 52. All right. Let's see what we're going to do from here. Let's see if you guys can figure out the next. All right. Did you think about it? So hopefully you recognize that all these numbers have a 4 in common. So we can essentially divide them all by 4. All right. So x squared and then plus 7x minus 13 is equal to 0. And then we want to know if this factors. Well, it's not, because remember the factors of 13 are just 13 and 1. There's no way to get 7. So we would want to punch out another quadratic formula here. So x is equal to negative b, so negative 7 plus or minus the square root of 7 squared minus 4 times 1 times negative 13 over 2 times 1. So we're going to type in 7 squared minus 4, right? So 7 squared minus 4 times 1 times negative 13 is 101. So negative 7 plus or minus the square root of 101 divided by 2. All right. And remember, we're going to the nearest tenth. So you want to think about splitting this up now. So if I did x is equal to negative 7 plus the square root of 101 over 2, and then or x can equal negative 7 minus the square root of 101 over 2. All right, so if we take a look at that, so x, we don't need the x. So it's negative 7, negate negative 7 plus the square root 101, parentheses, fraction bar, control divide, 2. We get 1.52 whatever, and change. We'll grab this and change it to a minus. All right, and we could say, like, we're not going to be able to add a negative amount, so my answer's got to be the positive amount. So x is equal to 1.5, or x is equal to negative 8.5. We're going to reject this because it's a negative amount. And so we would say the maximum, right, width of the pieces of wood, because they all have to be the same. That's what it's referring to here. Okay. We broke it. We just want to write that up. Okay, the maximum width is 1.5 inches. All right, on to the next one, vertex form. Remember, for vertex form, we're just completing the square. That's it, guys. Okay, so for the first one, we have x squared minus 12x plus 7. So we want to complete the square. So if it's negative 12, remember to do a negative b over 2 squared. So this is negative 6 squared, which is 36. So I want to get this number to turn into 36, okay? And it's already a 7. So it's kind of like, what plus 36 is going to equal 7? Whatever this is, that's what I want to change this number into. That's what I want to add on to it. So it's x squared, okay, minus 12x. I want to change this to 36, but I have to do something to this to make it positive 7. So I have to take something away from 36 to make it positive 7, and that would be negative 29. All right, 29 minus 36 gives me 7, so this is minus 29. This part is going to factor into x minus 6 squared. We have that minus 29 in, and then the a term, you can see it right there, is that negative 6, so we're good to go. All right, same thing on the next one. First of all, does it maximum or minimum? We know that this is a frowny face because it starts with that negative x squared, so it's going to be a maximum. Explain why. You can just say it, the leading coefficient is negative, or the x squared is negative, so it's concave down, so it'll be maximum. We're going to rewrite it into vertex form. So for vertex form, we want to get rid of this negative in front. Okay, so if we do this, we're going to do f of x is equal to, we're going to factor in negative 1 out right away, which is going to switch all our signs. Okay, then we're going to go ahead and do the thing we normally do. So we're going to do the b over 2 squared. So negative 8 over 2 squared is essentially negative 4 squared, which is 16. So we want to turn this into negative 1 x squared minus 8x, right, plus 16. And we want to make this 9. So we're going to do minus 7. And then we can bring the 7 out of the parentheses here, but we have to switch the sign when we do that, okay? So it's going to be negative 1 parentheses, okay? This is going to turn into x minus 4 squared. And because we're moving the 7 from outside the parentheses to inside, it becomes a plus 7, all right? So when we move it outside the parentheses, it changes signs. We can see our vertex now is the point 4, 7, all right? And you can always use your calculator just to check that if you needed to. That's vertex. Interpreting the graph, which represents the equation here. So if you look at our form, all right, the vertex is the point positive 15 and then positive 25. So I know my graph is going to look something like x minus 15 squared plus 25. It's also upside down, so there better be a negative in front, right? Okay, and it's also narrow, so that tells me that's going to be choice 4. All right. The same thing here, we're graphing and it's giving us the interval, so we're not going to use arrowheads, no arrowheads here, okay? Say the vertex and explain the meaning in terms of the problem. So we're going to graph our calculator, take our calculator, okay? New documents, no, I don't want to save, give me a graph, and then -8, and I'm just going to go x, I know it says t, but I'm going to use x because I'm using my calculator, all right, plus 40x, and then plus 5 because my graph is x's and y's. Now I can't actually see the top, but it's okay. When I go to menu, analyze graph, and I know it's a maximum value, it'll make it fit here. So we can see it's 2.5 and then 55. So if I need to graph, we're just going to choose appropriate x's and y's here. So we know we're graphing from 0 to 5, so I can actually space this out and count maybe by like every 3 spaces. So here's 0, there's 1, there's 2, there's 3, 4, and 5. And I know I got to get all the way up to 55, so maybe I'll count by, you know, 5s, but I'm going to skip a line. So there's 10, there's 15, I need 2s. That's too much, people. 1, 2, 1, 2, 1, 2, 1, 2. So there's 20, 30, 40, 50, and then 60. And I know I'm somewhere in there, okay? So I'm graphing just those points so I can do the table. All right, so at 0, we're at 5. So I'm going to put a point at 0, 5. Okay, at 1, we're at 37. So 1 is 30, just above 35 is somewhere right in that point. Okay, 2, we're at 53. So we're just above 50, not all the way to 55. All right, we know at 2.5, which is right in between here, we're at 55. And if you counted by 4s, or if you took 4 spaces in between numbers, just make sure you're appropriately placing it. Same thing here, we're going back down, okay, at 3, 4, we're at 37 again, and we know 5 is going to be at 5, so, and then we're just going to draw that curve in for ourselves, so, and I don't do arrowheads, so I'm going to stop right when I get to the bottom number, okay? So if this is the rocket here, right? We know that h is the height and t is the time. So this vertex, right, which has the point 2.5 and 55, tells us that, okay, the rocket reached its maximum height of 55 feet after 2.5 seconds. All right, that's essentially all it is. First one's 2.5, that's the time. Second one's the height, and that's the 55. All right, guys, thanks for sticking with me here. I know kind of a long video today, but we want to make sure we got all of quadratics because we just did it into one day. All right, I'll see you guys tomorrow.